Welcome to Boson Buzz, where we dive into the coolest scientific ideas and breakthroughs shaping tomorrow's world. The human body is a universe of silent conversations, a landscape of trillions of cells constantly living, dying, and communicating in a language written in chemistry. For most of medical history, we have been deaf to this conversation. We only noticed when something went catastrophically wrong, when a tumor grew large enough to be seen on a scan, or when symptoms became too severe to ignore. By then, the disease has often entrenched itself, having a head start that can be measured in years. Catching a disease like cancer early has always been a desperate race against time, a search for a single, invisible needle in a galaxy-sized haystack. We have relied on scans that see only the gross anatomy, on tests that look for late-stage chemical signals. It's like trying to understand a secret plot by only witnessing the final explosion. We have been forced to play detective after the crime has already been committed, searching for clues in the aftermath. The dream of medicine has always been to become prophetic, to sense the first faint whispers of illness long before they become a scream. To hear the body talking to itself, and to understand when that conversation takes a dark turn. That dream is no longer a distant fantasy. A new era of medicine is dawning, one that turns our very bloodstream into a vast, information-rich river, and we have just learned how to fish in it. This breakthrough lives in a place both intimate and largely unknown, the liquid highway of our blood. Every single day, as part of the natural cycle of life and death, cells from all over our body, from our brain, our liver, our bones, our colon, reach the end of their lives and break apart. When they do, they release their internal contents, including their long, coiled strands of DNA, into the bloodstream. These tiny fragments, known as cell-free DNA, are like microscopic messages in a bottle, cast adrift from every organ and tissue. For a long time, this genetic debris was seen as biological noise, a chaotic and useless soup. But then, researchers had a revolutionary thought. What if this wasn't noise? What if it was a news feed, a real-time bulletin about the health of every part of the body, delivered directly into a simple blood sample? The challenge was monumental. How do you find one specific, dangerous message among billions of harmless ones? The answer arrived not by building a better microscope, but by learning to read the hidden ink the messages were written in. It's a technology that doesn't just look for cancer cells, but deciphers the unique molecular signature of death itself, distinguishing a healthy cell's peaceful end from the violent demise of a nascent tumor. The secret lies not in the genetic message itself, but in the envelope it comes in. Imagine every strand of DNA in your body is stamped with a tiny, unique postmark that identifies which organ it came from. This postmark isn't part of the genetic code. It's a layer of chemical tags called methyl groups. These tags attach to the DNA in specific patterns, and these patterns are unique to each tissue type. The DNA from a liver cell has a different methylation pattern than the DNA from a heart cell or a lung cell. It's a biological zip code. In a healthy body, the cell-free DNA in your blood shows a predictable mix of these methylation patterns, reflecting the normal, peaceful death of cells across your various organs. But when cancer begins, the rules change. A cancer cell is a renegade, and its methylation patterns are a chaotic mess, a scrambled, abnormal version of the tissue it came from. The new generation of blood tests, known as liquid biopsies, uses advanced sequencing machines to read millions of these DNA fragments from a single vial of blood. Powerful algorithms then sift through this data, looking for those aberrant methylation patterns, the scrambled postmarks of cancer. They can not only detect the faint signal of a tumor's presence, but, by reading the specific pattern, can often pinpoint the postmark of origin, telling doctors with astonishing accuracy whether the cancer began in the lung, the breast, or the pancreas, all from a simple blood draw. The process begins not in an operating room, but in a calm clinic, with a routine blood draw no different from a cholesterol test. The vial of blood, a deep ruby red, holds within it the entire story. It is transported to a laboratory where technicians carefully separate the plasma, the liquid component of blood, from the cells. Within this golden-hued plasma float, the priceless fragments of cell-free DNA. These fragments are then purified and fed into a sequencing machine, a sophisticated instrument that acts as a high-speed molecular reader. It decodes every single DNA fragment it finds, letter by letter, and simultaneously records its unique methylation pattern, its biological postmark. This generates an enormous, complex dataset, a digital representation of the body's cellular newsfeed. This is where artificial intelligence enters the stage. The AI is the ultimate detective, trained on vast libraries of methylation patterns from both healthy individuals and cancer patients. It scans the data with inhuman speed and precision, ignoring the background noise of normal, healthy DNA decay. It is searching for an anomaly, for the faint, telltale signature of a rebellion. When it finds a pattern that matches the chaotic scroll of cancer, it doesn't just flag it, it analyzes the remnants of the original tissue signature to triangulate the source of the problem, producing a report that might read, "Abnormal methylation pattern detected. Signal consistent with stage 1 colorectal origin." It is a diagnosis born not from imaging a mass, but from interpreting the ghostly echoes of cells that have already died. The implications of this technology are so vast, they ripple across the entire landscape of medicine. Imagine a future where annual cancer screening is as simple as a routine blood test, capable of detecting dozens of cancer types from a single sample, long before any symptoms ever appear. This moves us from reactive medicine to proactive health defense. For individuals with a high genetic risk for certain cancers, it offers a powerful, non-invasive way to stay vigilant, to catch the disease at its most vulnerable and treatable stage. Beyond screening, for patients already diagnosed with cancer, the bloodstream fisherman becomes an invaluable spy. It can be used to monitor how well a treatment is working. If chemotherapy is effective, the level of tumor-derived DNA in the blood will plummet. If the cancer is developing resistance, new mutant DNA fragments will appear, signaling the need to change tactics long before a scan would show tumor growth. It can also detect the earliest signs of recurrence, finding a few rebellious cells that have survived treatment and begun to multiply again, a warning that comes months or even years earlier than any other method. This transforms cancer from a stealthy enemy into one that is constantly illuminated under a spotlight, its every move tracked and reported, giving patients and doctors a critical advantage in the long battle. As with any technology of such transformative power, the path forward is not without its challenges and profound ethical questions. The sensitivity of these tests is a double-edged sword. They can sometimes detect very early, slow-growing cancers that might never have become life-threatening, a phenomenon known as overdiagnosis. This could lead to unnecessary anxiety, invasive biopsies, and treatments for conditions that would have caused no harm, forcing us to rethink our very definition of cancer. There is also the terrifying specter of the false positive test that suggests a cancer that isn't there, sending a healthy person down a stressful and potentially dangerous diagnostic pathway. The cost of these sophisticated tests, though decreasing, remains high, raising urgent questions about equitable access and the risk of creating a two-tiered healthcare system. And then there are the deeper philosophical dilemmas. This technology gives us a window into the most private aspects of our biology. Who owns this data? How is it stored and protected? Could it be used by insurers or employers? Finding a single ominous DNA fragment in a sea of billions is a monumental technical achievement, but deciding what to do with that information and how to navigate the anxiety and uncertainty it can create is a human challenge that we are only just beginning to confront. We are standing at the threshold of a revolution in how we understand our own bodies. The era of the bloodstream fisherman is not just about catching cancer, it is about fundamentally changing our relationship with disease. We are moving from a model of late-stage intervention to one of early interception, from fighting battles on a field chosen by the illness to preventing the war from starting in the first place. The same principles are already being explored for a host of other conditions to detect autoimmune diseases, to monitor organ transplant rejection, and even to track the subtle biological changes of aging. This technology turns our circulatory system into a central information superhighway, offering a continuous, real-time health monitor flowing right beneath our skin. It is a testament to human ingenuity that we learn to look not just at the cells that live, but to listen to the stories told by the cells that die. We have learned to read the whispers in the blood, to become interpreters of the body's most intimate language. This is more than a new test, it is a new sense. a sixth sense for medicine, allowing us to perceive the invisible, to forecast the future of our health, and to finally step into the role of true guardians of the intricate, whispering universe within. If you found this as fascinating as I did, do me a huge favor and hit that like button. Share this video with anyone who loves science or just cool, futuristic tech. And of course, if you want to stay updated on this and other amazing breakthroughs, make sure you subscribe to the channel. Thanks for watching, and I'll see you in the next one.